Hi students, this week we are looking at Earth's structure. We are continuing from last week, where last week we looked at the internal structure, and this week we are looking at the crustal plate boundaries. So, after last week, do you think that the Earth you are standing on is solid? Do you think that it feels like if it's moving? Whether you feel it or not, the ground is always moving. The Earth is not a solid ball. It has 4 layers, one around the other. In the center, this yellow part here, is the inner core. Around the inner core is the outer core. These layers are very hot. They are made of metal. The next layer is made up of rock. It is called the mantle. It is very hot. It is partially melted rock and is bendy like tar. The layer is always moving. The top layer of the Earth is the crust. This is the layer that we live on. This layer is always moving. It includes the ground and the bottom of the ocean. The crust is made up of many pieces, just like a puzzle. These pieces are called plates. They fit together just like I said in a puzzle. So you see these black lines are boundaries, or where the plates meet together. Since the mantle is always moving, the plates too are always moving. So remember we said that this layer here is rock, right? And rock and liquid. And because the crust, right, and these plates are make up the crust, are basically floating on top of the mantle, it also is moving. The plates do not always move the same way. See? Some plates move past each other. As they move, they rub on each other. These plates have rough edges. They get stuck when they move past each other. They keep trying to get unstuck. When this happens, they move with a big, fast shake. The shaking of the Earth is called earthquake. Plates move as the mantle moves. This is called plate tectonics. So the movement of these plates, right? This is one plate in yellow, one plate in brown, one plate in orange, and they are moving in different directions. They move towards each other, they move away from each other, they move alongside each other, right? And these movements is plate tectonics. And when these plates move, we get a lot of different results. We get earthquakes, we get volcano buildup. Maybe these plates move away from each other and allow the lava to come up, right? If it's moved towards and crushed together, mountains forms. Deep canyons, or when they move away, the Earth is always changing. Now, this is not a fast moving anything, it's very, very slow. The same way you can't see a nails growing, even though it's moving, the same way the plates are moving very, very slowly. Now, who is this fella here? This is a German geologist or scientist, Alfred Wegener. I'm not sure if I'm pronouncing his name correctly, who proposed something called a continental drift. Now we have to stick a pin there. What is a continent? A continent is a very large piece of land, right? like the whole of Africa, which has many different countries inside of it, is a continent. And we have 7 continents, right? Even though in 1912 he talked about this thing called a continental drift, it was not accepted till 1950. Now you must remember this name because you're going to be asked about it at the end. He talked about Pangea, a supercontinent. Basically, as you see, all these continents joined up together millions and millions and millions ago. Like I said, we have 7 continents now, but at one point in time, scientists speculate that there was one big continent. Look at this map below. If you were given these as puzzle pieces, where would you put? Where would they fit? Now, anybody who has built a puzzle would look for pieces that look like if they could be joined or fit together. For example, right here, this piece looks like it could join to this piece. And this piece looks like it could join to this piece, and so on, and so on, and so on. The continent is like a very large puzzle piece. Look at this illustration. It looks at continental drift, one large supercontinent, which drifts because of plate tectonics and causing these continents to separate and become individual pieces, right? Continental drift is the gradual movement of the continents across the Earth. And why is this important when we are talking about plate tectonics? It is because these landform features, the continents and mountains and all these different things, happen mainly because of what happens below the Earth's surface, where it is we have the mantle, like liquid, have these pieces floating on top and they are moving. So again, another illustration of what it would have looked like when it is we had one continent here and then they drift apart because of this movement of the plates. So this is a theory. This is an idea, but we don't have a time machine that we could go back 50 million years ago. But what evidence do we have that this plate tectonic or the movement of plates and continental drift did indeed happen? First of all, the map of the world, the shapes match. We can see if we were to push them together, how they seem to fit together, like I said, a giant puzzle. So that is one piece of evidence. You know, the fact that they seem to break apart, just visually looking at them, suggests that maybe, yes, there is continental drift caused by plate tectonics. The second, now this is also important because you will be asked about it at the end. Fossils. Fossils are the remains of animals or plants that existed millions of years ago. And if we didn't have airplanes or they weren't pets or whatever, but millions of years ago, how then did this, whatever it's called, Cyanopernathus or whatever it is, and this one and this plant and this animal, how was it found in these 2 continents? And anybody who knows their globe very well would know that South America is nowhere close to Africa. There's a vast ocean in between. So it must mean, if we were to logically think about it, that this animal would have walked or crossed at some point in time amongst these, between these continents. There's this green plant that is found on all the continents. How did that happen? This one is found in 3 continents and this one on 2 continents. So the fossils that were found is a second piece of evidence that suggests that we were one big giant continent, and that because of plate tectonics and the continental drift, that is how we have the Earth as it is today. All right, so yet another illustration here. These are fossils we are looking at and where they are found. And look at this vast ocean in between. And there we find it again. And then look at this shape and look at this shape, and it seems to have pieced together quite nice. Another piece of evidence, the same rock structure or landforms are found on different continents. Take, for example, South America and Africa. This is the same rock structure that seem to have broken apart from the same area. Right? Then we have these mountains that seem to have once been joined, because look at where these mountains also are. Like a puzzle, you would put mountains together if you had to squish them together. See? These mountains seem to have broken apart. So, a little pause, and let's see, with this continental drift, if we took this penguin in Antarctica and he jumped into a time machine, where would Antarctica have been on the Earth 50 million years ago? And what did it look like? What? Antarctica would have potentially looked like this many years ago, well, 50 million years ago, before the continent drifted to the pole. Now, the pole would be the North Pole or the South Pole on the Earth, and we know that those are the coldest area, the Arctic and Antarctica. In fact, where he came from, it was all ice. But this would have been possible because of the continental drift. It means 50 million years ago, it would not have been ice, but this fossil of plants and animals found in Antarctica suggests that wherever Antarctica was on the Earth 50 million years ago, it was possible to maybe have a rainforest type environment. So again, Pangaea, a supercontinent, plate tectonics, causing movement and shifts very slowly. We're not talking about a year or two, we talk about 50 million years ago. All right? And now let's look at these. These are our boundaries of plate tectonics. So we have one big plate here, one big plate here, and so it goes. Another view of these. The Earth's crust and upper mantle broke up into sections called plate tectonics. These plates float on top the mantle like rafts, moving very slowly. So this is something you need to pay attention to, because it is your assignment as well, your group assignment. There are 8 primary plates and several more secondary plates that make up the Earth landmass. So you ought to know the 8 primary plates, and then you should be able to identify where the Caribbean plate is on your map, because that's where you live. Right, so let's list them out. We have the African plate. We have the Antarctic plate. We have the Australian plate, as in singular, even though on this map you would see 2. It is only because the globe is a sphere, and this map, when flattened, it will appear it is joining on either side, right? It does not mean that it is on 2 sides. Same goes for the Euro-Asian plate, making up Europe and Asia. Indian plate, North American plate, Pacific plate, South American plate. And then your group assignment. You are to complete the following activities and submit 1 to your Microsoft Teams class group. Firstly, name the scientist who first proposed that the world was a supercontinent. Secondly, what was the name of this supercontinent? Thirdly, give 3 pieces of evidence of the existence of a supercontinent, which also proves the theory of plate shifting below the Earth's crust. 4, review cycle 1 topic and list 2 materials which comprises of the mantle. What are some metals that you may find in the mantle? 5, draw a map of the world and label the 8 primary plates found on Earth. Now you can also print it, or it's available here. This is what I'm looking at. And which plate would you find under the Caribbean? What is the name of that plate? Okay, so that is it for this class, and I will see you next time to discuss.